Hi, I'm Chris Nolan aboard the sailing vessel Navigator in the West Indies. In this episode, we'll talk a bit about the parts to the marine sextant and how to use it to measure an angle between the horizon and a celestial object. The first thing to do is familiarize ourselves with the sextant itself. The marine sextant is a device used for measuring angles between two objects in the sky. It's nothing more than a glorified protractor. But in order to understand the concepts of celestial navigation and the sextant itself, we'll have to take a closer look at the parts to the device. The telescope enables the user to get an amplified view of objects. The shades come in various magnitudes and are used to dim bright objects such as the sun and the moon. The way the sextant actually works is by moving two mirrors in relation to each other. The index mirror moves while the horizon mirror does not. There are two ways to move the index mirror. The first is with the squeeze trigger on the index arm for gross adjustments. The second is with the micrometer drum, which is used for fine adjustments. Let's take a closer look at how to read the sextant. This sextant is set to 0 degrees and 0.0 minutes. Note that 0 is not all the way back on the sextant. A very small adjustment gets the sextant to 0 degrees and 1.0 minutes. 1 minute of arc on the sextant equates to 1 mile of accuracy in measurement on a chart. This is 0 degrees and 30.0 minutes. Note that the degree reading is noticeably not 0 anymore. Let's zoom in even a little bit further. Every sextant is a bit different, but as the micrometer drum turns, you can see the degrees change slowly. And you can get even more precise, down to the 10th of a minute in fact. In reality, this is far greater than the human eye can distinguish. In order to read the tenths on this sextant, you note which decimal on the vernier scale on the right most closely matches the hash mark on the left. Watch as we progress through the decimals. This is 0.2, 0.4, 0.6, 0.8, and 1.0. Here's a couple examples of how to read the sextant. This is 60 whole degrees and 0.0 minutes. This is 60 whole degrees plus 31.4 minutes. Don't get too caught up in reading the tenths. Remember that the human eye is not as precise as the sextant. Typically, an accuracy of 1 minute of arc is sufficient. When you're getting started in celestial navigation, the best place to start is with the biggest object in the sky, the sun. Now, when we measure the sun in the sky, we're actually interested in shooting to the center of the sun. But that's really difficult to do with the sextant, so what we do instead is we shoot to the lower limb of the sun. Let's use this orange to represent the sun. Theoretically, we want to shoot to the center of the sun. That's imprecise to do because it's tough to measure. So instead, we shoot to the lower limb of the sun. The picture we want to see through the sextant is the sun balanced on the horizon like a golf ball on a fairway. It's also possible to shoot to the upper limb of the sun with a different correction. However, this typically is not done. Instead, we always shoot to the lower limb of the sun. So I'm at anchor in Martinique in the French West Indies, and being an anchor is a great time to practice taking sights with the sextant. The first thing that I do is I set the sextant to 0. I read the instrument carefully to make sure that I'm actually at 0. Once I have the sextant set at 0, I set shades. I know that on a day like today I need 1 shade on the horizon glass and 2 on the index glass to make sure that I don't hurt myself, but you'll have to experiment with your own sextant. Be very careful not to hurt yourself by looking directly at the sun without proper protection. Once I have my shade situation figured out, I look through the telescope directly at the sun. I look quickly to make sure that everything is good and I'm not going to hurt myself. Once I'm satisfied that everything is good with the sextant, the first thing I do is I adjust the micrometer drum by about 30 minutes of arc while I'm looking at the sun. This allows me to separate the sun into 2 distinct images. In this case, we've exaggerated a little bit. It's about 4 or 5 degrees difference, so you can see that there are 2 distinct images of the sun. Once I've separated the sun into 2 images, I take the lower image and I follow it down to the horizon using 2 distinct images in the sextant. The first is that the index arm moves forward. The second is that the sextant itself comes down to the horizon. Together, it looks like this. So when I take the sight, I do those two distinct motions and bring the sun down until it's just about at the horizon. Once it's close to the horizon, I use the micrometer drum to fine-tune the adjustment. Keeping the sun in sight the entire time, the index arm moves forward as the sextant comes down. We get the sun as close to the horizon as possible. Once I've got the sun pretty much there and I've adjusted it with the micrometer drum, the last step is to swing the sextant in an arc while adjusting the micrometer drum so that the sun pitches an arc through the image and touches the horizon at the very bottom of the arc. This ensures maximum accuracy. As the sextant rocks back and forth, the sun traces an arc through the image. We want the lower limb of the sun to touch the horizon at the bottom of the arc. Once I've got it, I note the exact time to the second, read the sextant 2 or 3 times to make sure I didn't make a mistake, and do some calculations. There's a couple other ways to take the sights that you may have been taught or seen people doing. One way is to pre-calculate how high the sun should be or make a logical guess. Set the sextant to that angle and then simply sweep the horizon until you're close. Once you get there, you adjust with the micrometer drum, swing the sextant back and forth until you have it exactly right, and then record your time and measurement. Another way to do it is to invert the sextant by turning it upside down. What that enables me to do is instead of bringing the sun down to the horizon, I bring the horizon up to the sun. That way it tends to be a little bit more complicated for beginners, but it's out there if you need it. Either way, the important thing is to note the exact angle and the exact time to the second that you measured that angle. The actual act of measuring a celestial body is probably the most important aspect of celestial navigation. It's where the most common errors occur. So the good thing is you can sit at anchor or sit at home on a winter's day and practice taking measurements to your heart's content. You can use the horizon at a beach, or you can purchase or create an artificial horizon and use it at home so that you can practice enough so that when you're at sea, your measurements are second nature. In this episode, we've talked a bit about the parts of the marine sextant and how to use it to measure an angle to the sun. Practice the techniques you've learned, refer to the notes at the bottom of this lesson, and when you're ready, we'll move on.